Good morning, afternoon, or night whenever you're watching this. This is the video for Algebra 1A, solving equations. And the first thing you should be doing right now is you should be taking out a paper. You should be writing down your notes. These are the vocabulary words that I want you to take into consideration, right? So make sure you have these words written down, right? Equations, a mathematical sentence that uses an equal sign to show two expressions are equal. Constant, a fixed value or a number on its own. A variable, a symbol for a value we do not know yet, usually in the form of an x, right? In operation, it's the directions on what to do, such as it's telling you, hey, multiply this, or divide this, or add this, or subtract this. And usually they're shown by either the symbols for multiplication, division, addition, or subtraction. That's what an operation is. Inverse operation, inverse just means the opposite. So inverse operation is just the opposite of a specific operation. Whenever we're going to use this term a lot throughout this lesson, so that's why I need you to know what it is. I need you to write it down, right? Multiplication is the opposite of division, right? Because when you multiply something like 3 times 3 to get 9, in order to get the original number back, you need to divide 9 by 3, and you get 3 again, right? That's why they're opposites. One undoes the other, right? The same thing with addition is the opposite to subtraction. Those are two things that you need to know, all right? And coefficients. A coefficient is just a constant in front of a variable, which implies that a constant and a variable are multiplying. So for example, 5x just means 5 times x, or 5 multiplying by x, okay? Now, before we get started on the rest of the lesson, I want to go over an equation, right? So let's say we have x plus 5 equals 15. Now, an equation, as shown by the definition up there, is a mathematical sentence that uses an equal sign to show two expressions are equal. Really what that's saying is, in equation, there's always going to be a left side of the equation and there's going to be a right side. You're going to see me say this a lot. And I want you to understand what this means. Okay? So the equation is always going to be in the middle. The equal sign, sorry, is always going to be in the middle. To the left of the equal sign is the left side of the equation. And the left side of the equation currently has an x plus a 5. It has a variable, right? My x would be my variable. My plus is my operation, right? And the 5 is the constant, right? Okay, and then the 15 right here is another constant, right? And if you notice, it doesn't have anything here, right? All right, so if you notice it just doesn't have anything there. And that's fine, because the right side of the equation just has one value. It's just 15. The thing that makes us an equation, it's we have the understanding that the left side of the equal sign is going to be the same as the right side of the equal sign. And your job this week is to prove that both sides are equal, right? We're telling you that x plus 5 is equal to 15. We want to know what x is because we don't know what it is. What number would make this the left side equal to the right side is really what solving an equation actually means, okay? So why don't we go ahead and get started, right? You should have all this written down. This is the first thing I should see in your notes, because the first assignment should be to make sure you have your notes, because you're going to upload a picture of your notes. So hopefully pause this video, write everything down. Once you're ready, move on. All right, so here, one-step equations. One-step equations are equations that can be solved using one inverse operation. Now, what do I mean by an inverse operation? Well, here I have x plus 15, right? That is my equation. All right, I'm right here. Step 1, identify your equation. Okay, so I know that my equation is x plus 5 is equal to 15. Cool. Notice that the left side is x plus 5 and the right side is 15. We've kind of already gone over that in the previous slide, so that's okay. Step one is just recognizing that this is an equation, and because it's an equation, the left side is going to be equal to the right side. Understand that before you get started. Okay, cool. Now, step two. Our job here is to figure out what x is. That is what we're trying to do. So step two is to identify the operation. In this case, it's addition, right? That's why I have a plus in parentheses there, right? How do I know that it is? Because look, over here, that x plus 5, that is the only operation that I have in this equation. The left side of the equation has an operation, the right side does not. You'll have times when you have operations on both sides. In those cases, you're just going to have to decide which side you want to work on first. In this side, there's only an operation on the left side, so that is my only operation. I've identified that it's addition, okay? So now, in order to get rid of it, in order to move forward in this problem, I have to use what's called inverse operations, right? Now, inverse operations, if you remember from the definitions, just means the opposite. Do the opposite. So what's the opposite of addition? Well, according to this, it's subtraction, right? So we're going to use inverse operations, in other words, subtraction, to isolate the variable. We want that x to be by itself. Currently, that x is not by itself. That x has a plus 5 on it, and we need to get rid of that plus 5. In order to get rid of that plus 5, we need to do the opposite because we need to reduce it to 0. So instead of a plus 5, we're going to subtract 5. That's why we have a subtraction here, right? Plus 5 minus 5, this whole thing cancels out, right? And I have x by itself on the left side of the equation. However, I can't just take away 5 from the left side of the equation. I have to do it from both of sides. Remember, this is an equation. If I take away 5 from the left side, the equation is now unbalanced because I took 5 from the left. In order to balance it, I need to take 5 from the right as well, which is why I have 15 minus 5 here, right? So that's why I have to subtract 5 from both sides of the equation. That way, if I take an equal amount from both sides, the equation is still balanced, okay? So that leads us to step 3. Well, the 5's canceled out, and I'm just left with x on the left side of the equation, right? And 15 minus 5 is just 10, right? So that means that my x, one of my x's, is equal to 10. That is my final answer, right? This leaves me my isolated variable. My variable is by itself. That's what isolated means. 10, which is my answer. I'm going to check my work now, right? We moved on to this part where I just rewrite the equation. If I'm not sure if I did this right, all I have to do is take my answer, which is x is equal to 10, replace or substitute my x with 10 and see if it still makes sense, right? Check your work by rewriting your equation, then substituting 10 for your x. Does the left side of the equation equal the right side of the equation? If so, your answer is correct. If not, you made a mistake. Okay, so x is 10 now, right? So this is my original equation. Then I replace x with 10, so 10 plus 5 is equal to 15. And of course, 15 is equal to 15. So yes, my answer is correct. That is how you solve a one-step equation. Mind you, I just want to point something out. Let's pretend that my answer was, my equation was this, right? Let's say it was a subtraction instead of an addition. When I'm doing inverse operations, I'm doing the opposite of whatever the operation is. So if this was my problem, right, the opposite would be adding 5 to both sides, right? So in this case, this still cancels out, but the result is different. My x would be 20 in this case, okay? So just remember, you always want to identify what the initial operation is because you're always going to want to do the opposite of that. So in my original problem, it was x plus 5 is equal to 15. And I had to do some subtraction because it's subtraction is the opposite of addition. But in this side, right, in this second problem, we originally had subtraction, which means I had to add. And as you can see, that makes a huge difference because my answer is different, right? In my first problem, my answer was 10. In my second problem, my answer was 20. And yet the equation is still balanced for both. Okay, Go ahead and make sure you have all this written down, including all the steps. I need you to have them in your notes. All right. Pause the video if you don't. All right. If you already have everything written down, move on to the next thing. All right. Two-step equations. This is the next thing. So two-step equations is just an equation that requires at least two inverse operations to solve. It's the exact same thing that we did before, except there's an extra step involved, and this is what it is. All right. So two-step equations. We're going to start with the equation right here. Our problem is 5x plus 25 is equal to 50. All right. So step one, identify the operation being used. In this case, my only operation is plus, right? Because it's 5x plus 25. So if that's my original operation, we need to use inverse operations. So what's the opposite of addition? The opposite of addition is subtraction to isolate the variable 5x. Now, that variable, if that variable looks different, it's because it is. In the previous problem, I just had a regular x. This time I have a 5x. We're gonna deal with that later. But for now, just treat it as if it's one single thing, right? Right now, we're just dealing with the inverse operations to get rid of the 25. Because remember, we want the x to be by itself, and that 25 is in the way right now. So we need to subtract 25 from both sides. We need to subtract it from the left side of the equation, and we need to subtract it from the right side of the equation. So if we subtract, if you notice here, I have a negative 25 underneath it, plus 25 minus 25, they cancel out, right? Nothing happens to the 5x because you can't subtract 25 from 5x. They're not compatible. But if we take away 25 from 25, we get 0, right? And that's me taking away 25 from the left side of the equation. I still need to take away 25 from the right side of the equation. 50 minus 25 gives me 25. So now we're going to move on to the next step, right? We're now down here. We have 5x is equal to 25, right? That moves us on to step 2. We're not done with the problem. 5x is equal to 25. That x is not by itself. It still has a 5 attached to it, which means we got to get rid of the 5. So we're going to do the same thing. We're going to identify the operation between the coefficient, right? Remember, I'm going to use all these vocabulary words. If you don't remember what this means, look at your notes. You should have them written down in your notes right now. Okay. The coefficient is just a number that's in front of the x, right? Is in front of the variable. And they're always going to be multiplying. A coefficient implies multiplication. So in this case, I've identified that 5 is multiplying by x. So the inverse operations, what's the opposite of multiplication? You remember from the definitions, it's division, right? So in order to get rid of that 5, we got to get rid of that 5. X needs to be by itself. So how are you going to get rid of the 5? If 5 is multiplying by the x, we need to divide both sides by 5, right? Because anything divided by itself is just going to give me 1. And that's going to give us 1x, right? So in this case, I'm going to divide both sides. That's why now I have a fraction, right? 5x divided by 5. 5 divided by 5 is just 1. And that cancels out. The x doesn't cancel out, by the way, just the 5s. So I'm left with just x by itself, which is what I wanted. It's going to be equal to whatever 25 divided by 5 is. Now, if you put that in your calculator, you find out that it's just 5, right? Now, I have a step 3 here, right? My step 3 just says round if you need to or simplify. If not, then this is your answer. What I just meant by that was like if you ended up with a decimal for some reason, because whenever we divide, sometimes we end up with decimals, you would need to round your decimal. If you ended up with some kind of fraction, you would need to simplify your fraction to make sure it's as small as possible. We didn't end up with either of those. We just ended up with a constant. We just ended up with a regular number. X is equal to 5. Since we ended up with a regular number, that's our answer, right? That's it. Our answer is x is equal to 5. Now we could check this answer. We could put it back, right? So if we know x is 5, we could put it back into the original equation. 5x plus 25 equals 50. 5 times 5, because remember, the 5 is multiplying by the x, but now x is 5, plus 25 equals 50. 5 times 5 is just 25, plus 25 equals 50. And of course, 25 plus 25 is 50. So 50, does 50 equal 50? Yep. This is a balanced equation. I have solved my two-step equation. Make sure you have this written down. If you do not, take a minute, pause the video, then move on. All right, moving on. Word problems. Okay, so the word problem. An ostrich that is 108 inches tall is 20 inches taller than 4 times the height of a kiwi. What is the height of the kiwi in inches? Okay, so a couple things here before we even get started. Don't be afraid of word problems. They're going to be confusing, yes. But really, what this is you're just going to have to come up with an equation that models what the problem is asking you. Okay. Now, that sounds a lot harder than it actually is. All right. Really, what's going on is most word problems are going to be comparing two values because this is an equation. Remember, the left side of the equation has to equal the right side of the equation. All you have to do is figure out what information should go on the left side of the equation and what information should go on the right side of the equation. Um, by the way, a kiwi in this problem doesn't mean the fruit; it means a type of bird. So if you guys know how tall an ostrich is pretty tall. Um, don't picture four little kiwis like the fruits. They're actually four small birds stacked on top of each other, right? Yeah, I know that's equally ridiculous, but just go with it. This is a math problem. Okay, so right, an ostrich is 108 inches tall, right? So we know that that's a fact. That is being compared, right? Now, if you notice, I have an interpretation that's typed out. This is what I was thinking when I was solving this problem, right? Okay, so I know I'll need to create an equation using the information. So what information do we have? Well, we have the height of the ostrich, and it's being compared to the height of 4 kiwis plus 20 inches on top of the height of those four kiwis. So that means that the height of the ostrich would be on my left. There's supposed to be a space in between there. Left side of my equation, as it equals to the height of whatever the height of the kiwi is 4 times. So that's a 4W, because remember, 4 is multiplying by W. So that's how we get the 4W. And 20 more inches. So plus 20. The more implies addition, right? And it's these little connections that you're just going to have to make. And I'll help you with most of these on one-on-ones. If you Zoom with me, I can help you with these if you're having trouble. I just want to see what you're thinking. I just want to see you try. Okay, so in this case, the equation, right? I came up with 108, all right, is equal to 4W plus 20. I created the equation using the information from the word problem. This is going to be the hardest step for most of you. But once you have an equation, just go with it. Even if you're not sure if it's correct, go with it. And then if you get it wrong, then you get it wrong. I'm not going to take off points because you got it wrong if you're showing all your work. If you show all your work and I see where you went wrong, I'm just going to point it out, and then you're going to fix it, and then you're going to move on. That's it. All right. So 108 is equal to 4W plus 20. Cool. Step one. That's my equation. All right. Now we move on. Step two. Right? Identify the operation used. So in this case, again, the only operation that I have here in my original equation is plus, right? So that's my original operation. I've identified it. I know it's plus. So I need to use inverse operations now. The opposite of addition is subtraction. So now I'm going to have to subtract whatever I was adding, right? So in this case, I was adding 20. I need to subtract 20, but I need to subtract 20 from both sides in order to finish isolating the variable, right? The variable in this case is 4W, right? So I'm going to subtract 20 from both sides. Now, remember, if I subtract 20 from the right side, the 20 is canceled out, and that leaves 4W by itself on the right side of the equation, which is good. That's what I wanted. But I have 108 minus 20 now. So I'm just going to have to subtract that. So 108 minus 20, right, is equal to 88. So now we're down here. So now we have 88 is equal to 4W. Now I need to do step three, right? Step three, identify the operation between the coefficient and the variable. So what that means is what is the 4 and what is the W doing, right? So the 4 and the W are multiplying, which means that in order to do inverse operations, right? What's the opposite of multiplication? It should be division. in order to isolate the variable by dividing both sides of the equation by 4. In order to make sure the variable is by itself, I need to get rid of that 4. And the only way to get rid of that 4 is to divide it by itself. So divide both sides by 4. Now, 4 divided by 4 just gives me 1. That cancels that out. 88 divided by 4, however, ends up being 22. My W by itself is worth 22, which means that the height of that weird bird, that kiwi, is 22 inches tall or whatever. So yeah, that's how you do a word problem. If you're still confused about word problems, that's okay. We need to go over them in person or through one-on-ones in a Zoom. All right. So if you're still confused, message me and we can set up a Zoom appointment. All right. Zooms are by appointments only because I don't know when you guys are available. All right. So, okay. So there is an extra layer of difficulty in these problems. Those are the kind of problems you're going to have to do. This, however, I don't know if you guys can see this, right? Is I'm going to teach you guys how to deal with fractions, right? Because the biggest difficulty that a lot of students have with solving equations isn't what I just showed you. Like most people get that after like a couple of tries. What they have trouble with is when they see fractions, because most people freak out when they see fractions. And that happens. But I'm going to show you what to do when you need to add fractions, subtract fractions, multiply fractions, and divide fractions. And then we're going to do a problem where we're going to do the hardest versions of those. Okay. So we're going to start here with adding fractions. So I'm going to add 1/3 plus 2/3, right? There's two different examples for adding fractions. Whenever we have, if you notice, the key with adding fractions is the denominator. Now, if you don't remember, right, we have what's called the numerator and we have what's called the denominator. The numerator is a number on top of the fraction. In this case, the 1/3, right? The numerator equals the 1 and the denominator equals the 3. The denominator is just the number that's on the bottom of the fraction. The key to adding any fraction is if they have the same denominator. In other words, if the bottom number is the same for both fractions, it's really easy. You keep the same denominator, right? The 3 is going to be part of my answer, and you just add the two numerators. 1 plus 2 is 3. So my new numerator is 3. My denominator is the same as my previous denominators, which is 3. 3 divided by 3 is just 1. So my answer ends up being 3/3, or it can be 1. That's called simplifying when I did the 3 divided by 3, right? So, okay, cool. If they have the same denominator, just add the numerators, you're good, right? Okay, so now we're going to move on to the bottom part, this little complicated thing that we have going on here, right? Okay, so what's going on here? What's going on here is I originally had 1/3 plus 1/4. This is what you need to do if you do not have the same denominators. Like the 3 and the 4 are not the same. And I'm not allowed to just add them together because we need to have the same denominator in order to add the numerators. So what am I going to do? I'm going to do something that'll work. There is a shortcut to this, but I'm not going to show you the shortcut. I'm going to show you the long way, and I'm going to ask that you do it the long way. If you know the shortcut already, go for it. You do the shortcut. The shortcut is just, greatest common factors or whatever. But if you've never heard of that, do this. You need to change the way these fractions look so that they have the same denominator. And the way that we do that is you're going to multiply these fractions, right, by the other fraction's denominator. This is why I separated them, right? I separated them because each one is going to do its own thing for now, right? The 1/3 needs to change so that it has the same denominator as the 1/4. And the only way to do that is to multiply it by the opposite denominator, by this 1/4. The 4 specifically. So the 4 is going to come over here, right? And I'm going to multiply it. Whoops. I'm going to multiply it by 4/4. Why am I doing that? Where did I get the 4/4 from? Well, the fact is that any number divided by itself is just 1. So 4 divided by 4 is just 1. So really what's going on is that 1/3 that I have there is technically multiplying by 1. And any number multiplying by 1 is just itself, right? So you might be wondering, why would I do that? Nothing's going to change. Well, yes and no. I'm not changing the value. The value is still going to be 1/3. I'm changing the way it looks so that it's compatible. So in this case, I have 4 over 4 times 1/3, right? 4, then I multiply the numerator times the numerator and the denominator times the denominator. When we go over multiplying fractions, this is going to be a little redundant, but it's okay. 4 times 1 is going to be 4. And 4 times 3 is going to be 12. We are allowed to multiply the denominators together because this is multiplication. I know it's weird, but just kind of following with this. Okay, that's going to be plus. Now, we need to do the same thing with the 1/4 because now we have a 12 in the denominator, right? By the way, 1/3 and 4/12 is the exact same fraction. They represent the same thing, okay? We're going to do the same thing to the 1/4, except we're going to multiply by the opposite denominator, right? This time, however, I'm going to multiply the 1/4 by 3 over 3 because 3 divided by 3 is just 1, right? But I'm changing it to make sure that there's a 12 underneath it because now what happens is 1 times 3 is going to be 3, but 4 times 3 is going to be 12. And if we look at that, now we have the same denominator. This trick will work every single time. It might be a little longer than the shortcut, but it's less confusing. The shortcut is when you already mastered this, right? Okay, so in this case, we're adding, right? So 4 plus 3 is 7. And 12 and 12, remember, we're adding now. So we just keep the same denominator. This is exactly what I did up there. You see how I have it all kind of like organized in a straight line, right? It's the exact same thing. You just saw me do it in real time, but I had it up there written in a more concise way. Okay. Okay. So hopefully you got that. Rewatch it if you need to. We're moving on to subtracting fractions. Okay, so we're up here at the top now. So we have 2/3 minus 1/3. Again, if they have the same denominators, all you have to do is just subtract the numerators. 2 minus 1 is 1. My answer, 1/3. I'm done. Cool. Sounds easy. What's not easy is what I have down here. The original problem is 2 over 3 minus 1 over 4. Once again, I'm gonna close these off for a second. I'm gonna separate them and I'm gonna make sure that they have a common denominator. So I'm gonna do the same thing. I'm gonna multiply 2/3 by the opposite denominator. So it's gonna be times 4 over 4. So 4 times 2 is just 8. 4 times 3 is 12. I bring this down, right? The minus. And then I'm going to multiply the 1/4 times the opposite denominator, which is 3 over 3. 3 times 1 is just 3. 4 times 3 is 12. Cool. Now I have the same denominator. Now all I have to do, right, since I have the same denominator, I can start with the denominator as something over 12. And then I just subtract the numerators. 8 minus 3 is just 5. And my answer is 5/12. I did the exact same thing up here. I just did it, horizontally, right? I just did it from side to side. But some students find that confusing. If you find the vertical one better, use the vertical one. It's the exact same thing. Okay, so hopefully that clarified a couple things about what to do, right? Now we're going to move on to multiplying fractions and dividing fractions. Now, multiplying fractions, you kind of already saw what multiplying fractions is. Multiplying fractions is really easy. 1/3 times 2/3, you're just multiplying numerator times numerator and denominator times denominator. So 1 times 2 is just 2, and 3 times 3 is just 9. My answer is 2 over 9. That's it. I'm done. The only difference is, what if you're multiplying a fraction times a whole number, which is what you're going to be doing in the problem, right? Most of the times when you want to get rid of a fraction, you're going to multiply by the denominator. And what I mean by that is what I have right here. 1/3 times 3. What's actually going on here is it's 1/3 times 3/1. A whole number is just like a regular number. And if you want to turn a regular number into a fraction, all you need to do is divide it by 1, because anything divided by 1 is just going to be itself. So I'm not changing that 3 by making it into a fraction. I'm just changing the way it looks by dividing it by 1. So really, it's 1/3 times 3/1. And then when I multiply across, 1 times 3 is 3. 3 times 1 is 3. My final answer, 3/3. Okay. And by the way, that turns into 1, which is why whenever we multiply, they'll cancel out and they'll equals 1. That's a shortcut. Okay. Okay, so we're going to move on to dividing fractions. And I have KCF, keep, change, flip. You might have heard that. The key to dividing fractions, right, is order matters, right? Because for multiplying fractions, if I have the one, it doesn't matter if I have the 1/3 first or 2/3 first, I'm going to get the same answer. But when you're dividing fractions, that matters a lot. The first number is the most important number because that's the number that's being cut up into the second number, right? So in this case, 1/3 divided by 2/3, I'm going to keep, change, and flip. So what that means is the first number, 1/3, is the important one. I'm going to keep that exactly the way it is. Then I'm going to change division into multiplication. That's what the change means, right? Then flip. The numerator and the denominator switch places so that it's like this now. That's what that means. So if my original problem had 1/3 divided by 2/3, the 3 and the 2 are going to switch places. So then that, you notice I have an equal sign, right? 1/3, I kept it. I changed the division into a multiplication. And then I switched the 3 and the 2 places. I flipped them so that now this becomes a multiplication problem. And then now you can just multiply the numerator times the numerator, or 1 times the 3, which gives me 3. That's how I got this 3. And then the denominator times the denominator, 3 times 2, which gives me 6. And then I'm going to simplify, because 3 divided by 6, I can divide the top and the bottom by 3, right? 3 divided by 3 is 1, and 6 divided by 3 is 2, and I end up with 1/2, right? Okay, by the way, just so you know, 1/3 divided by 2/3 is the same as 1/3 divided by 2/3. If you notice, the top is being divided by the bottom, which is why the 1/3 has to be the first number, and then it's being divided. Order matters because that's really what's going on. Okay, last thing, I swear, I know this has gone on for a long time. Right, take a break if you need to. Two-step equations with fractions, right? So we have 1/3 y, we're over here, right? I know this is a big jumbled mess, but we're over here. And this is my original equation, right? 1/3 y, in other words, 1/3 times y, plus 1/4 is equal to 5/12. All right, this is kind of complicated. We're going to use what we learned earlier. We're going to use everything that we've learned to solve this equation, because we need to solve what y is. So since we need to isolate 1/3 y, we need to get rid of that 1/4. It needs to go away, which means that the only way to make it go away, since we're adding 1/4, we need to do the opposite, and we need to subtract 1/4 from both sides. 1/4 minus 1/4, that's easy. It just cancels out. That's 0. What's hard is 5/12 minus 1/4. So then I'm going to show my work here, right? 5/12 minus 1/4. I'm going to do the trick that I learned. I'm going to separate them, and I'm going to multiply by the opposite denominator. In other words, 5/12 is going to multiply by 4/4 minus 1/4 times the opposite denominator, which is 12. So it's 12/12 this time. 4 times 5, right, gives me 20. And 4 times 12 gives me 48. That's where I got this from. The other one is 1 times 12, which is where I got this 12 from. And then 4 times 12 is exactly where I got this 48 from. Notice, now that they have the same denominator, I'm allowed to just subtract the numerators. In other words, 20 minus 12, which gives me 8, right? 8 divided by 48, I can divide the top and the bottom by 8 because they're factors. And that just means that 8 divided by 8 is 1, and 48 divided by 8 is 6, which means I have 1/6. In other words, 5/12 minus 1/4 is equal to 1/6. So now that this became this, the 1/3 y just came down, right? So 1/3 y is equal to 1/6. This is my new problem now, right? I need to do inverse operations again, because this time I need to get rid of the 1/3. Now remember, this is where it gets a little confusing. 1/3 is technically multiplying by the y. Now the operation that we've identified is multiplication, which means to get rid of that 1/3, I'm technically supposed to divide, but a fraction is already division. So what you'll see me do in the future is I'm going to do a shortcut where in order to get rid of a fraction, you just kind of multiply by the denominator. However, here I'm going to show you the long way because I need you to understand why the shortcut works. So 1/3 y is equal to 1/6. To get rid of that 1/3, I have to divide, which is why I have that long line, by 1/3. 1/3 divided by 1/3, right? Since they're multiplying, it should, in theory, cancel out. We'll talk about what that actually looks like later. But here, the key here is 1/6 is also being divided by 1/3. Since the 1/6 is the one that's being divided, I have to keep the 1/6 exactly the way it is. I'm going to change the division to multiplication, and I'm going to flip the 1/3. Okay. So in other words, 1/6 times, because remember, this turns into multiplication, and then I flip the 1/3. The 1 and the 3 switch places, so the 3 is on top, it's my numerator, and the 1 becomes my denominator. So now it becomes a 1/6 times 3/1, and it's a multiplication problem now. So 1 times 3 is just 3, and 6 times 1 is just 6, and then I can divide by 3, divide by 3 to simplify. 3 divided by 3 is 1, and 6 divided by 3 is 2. My answer is 1/2. Y is equal to 1/2. Okay, so full disclosure, how many of these two-step equations am I going to make you do with fractions? I'm going to try to keep it to a minimum, but you will see some of the problems. If you skip them, I will take points away. If you don't show your work, I will take points away. If you just have answers and no work, I'm going to give you a 0. I'm going to ask you to return in your work again. This is how this class works, okay? You need to pause the videos, write down notes, show me all your notes. You're going to take pictures of your notes and upload the pictures for credit. That is your notes. Then you're going to do the warm-ups. Warm-ups are due every day, right? Monday, you're going to get a different warm-up. Tuesday, you're going to get a different warm-up. Wednesday and Thursday, you're going to get a different warm-up, right? For points every single day, and they're due that day. And then you're going to get a worksheet, something with additional practice for you to do, with a certain amount of problems to do every day. Those 4 worksheets, because there's going to be about 4 worksheets in a week, are going to be due by Sunday. But if you do them all every single day, you'll be done by Thursday. Yeah, you'll be done by Thursday. If you log in every day and do all the work every day, and you contact me through Zoom when you're having trouble, you can have everything done by Thursday. If not, and if you wait till the weekend, this is going to feel like a lot. All right. So, not that it can't be done, some students have done that, but if you're the kind of person that is struggling with math and need help, do not wait until the weekend. Contact me immediately so that I can help you. All right. Contact a tutor, contact someone else. But don't just wait until Sunday, say, I don't get it, and then you're behind because after Sunday deadline, I'm not accepting work. Right. If an emergency happens, you can contact me and, maybe I'll let you submit something late, but even then, I'm not going to give you that much time. This is a 5-week course. You missed 1 week, that's 20% of your grade gone. You missed 2 weeks, it's impossible to pass. So, with that said, good luck. I believe in you guys, and that's all.